This has just been the tip of the iceberg. There is more coming, including on the cyclical catastrophes and the evidence for them. The evidence for it being a combination of the stories we've heard thus far. We'll be digging deeper into other potential mechanisms for the flip, begin tweaking how we monitor the low velocity zone of Earth, and begin to include those alerts in our app notifications if we are ever so unfortunate as to need them in the future. The basic point today is this. Of all the works to classify, they classified the only one that could not be umbrella debunked by looking over long periods of time. Even if this was a CIA operative report, which would explain the initial classification, it has still been sanitized with pages missing and random inserts in the document that may or may not be supposed to be there. The only reason that the cyclical catastrophe is not a prominent part of modern understanding is that the mechanisms proffered by Velikovsky, Hapgood, and others would not stand the test of time analysis of Earth's rock alone, without additionally accounting for the repetition of the pole position. It should be known that in the 60s, we did not yet know about the geographic poles and their holding of long-term time average stability, and it was not part of the reason for the theory. The theory came before the awareness geophysically. Our analytical tracking of magnetic pole positions to the same predicted locations as in the classified work was first presented to you all in January of 2016, 11 months before this document was released to the public. To be clear, there is no definitive statement that can be made on the validity of the hypothesis in the declassified work. We cannot say anything about its original reason for classification, what things have been sanitized, or why they are not fit for distribution. What we can tell you definitively is that the evidence of this catastrophe is everywhere and convincing and spans fields from mythology to geophysics. The one version of the story that is rife with patterned chaos and fits the description used to debunk the others is the one they classified. These catastrophes are well preserved in rock and in story, and we are supposedly a few thousand years past the last cycle catastrophe. We could have a few thousand years left, or we might not. More coming here on our website and on the Suspect Sky YouTube channel over the coming weeks. Eyes open, no fear. Be safe, everyone.
Okay, so essentially, right here is where I think the lesson ends, or the part A of this, of what happens during the magnetic pole shift or reversal. There's 4 different scenarios, essentially, we gave, as I said at the beginning of this, the first one, the summary. All right, so that answers part A, but there's still the overwhelming question of, well, how does this affect the Schumann resonances? Okay, so I'm going to answer this more in, I think, the next video, but I have a little bit of time at the end of this one that I want to just generally go over some basic principles here. All right, so the first one of this is a matter of, there's a first general principle here of the shifting poles is making all of the weather climates shift and move. That's the first thing. So the general overall answer, the first tier answer to how it affects the Schumann is that it just moves the resonances in places of where it bounces, but it does not significantly change them at up until the very end, when everything goes kind of haywire. So the Schumann resonances as such are not going to be affected, in the same way as the jet stream is, because these move through a vacuum. All right, so there's part of the answer there. However, what we're looking at is something else as well. Okay, so that's a part of the answer, but that does not answer the overall question. This is, as we're moving in, they're not going to be affected that much, but they will be, and here's why. One of the things we're looking at is the global, all right, here we go, the global lightning density. These are one of the things that we're looking at here is the global lightning density. Okay, now this here in the United States, the total lightning density in 2019. Okay, we're looking at this chart. Okay, this is the real-time lightning meter. You see where a lot of these are toward the equator? Okay. Okay. You look at a lot of these toward the equator. This represents where the jet stream is kind of coming down. Okay. So I had an image up that I wanted to show. All right. That was it. All right. That was up before. Okay. As I'm blithering on about this. All right. So this is the density in the United States, the contiguous density in the United States. This is like Tornado Alley here. This gets a lot of crazy weather out here, okay, out in the Midwest, okay. They get storms here like hurricanes down here in south. But you see, the worst of it is kind of in the southern part of the United States where they get, like I said, they get tornadoes. All right. So I wanted to read to you what's important here is the 2019 lightning around the globe. All right. So lightning hot spots in the Western Hemisphere include areas in the Great Plains and Gulf, actually, here we go, and the Gulf Coast of the U.S. into Central America and the northern and central parts of South America. Tropical locations near and either side of the equator have the most lightning in the Eastern Hemisphere. This includes an area from Central Africa to Eastern India and much of Southeast Asia. One particular spot that stands out is the Dominican Republic of the Congo in Central Africa. Vesla, that's the name here, noted that one lightning bolt was detected within 110 miles of the North Pole last year, setting a Guinness World Record for the most northerly lightning detected. Okay. Most of the lightning in the world is detected over and near land areas. Since land areas heat up faster than water, there's a large amount of unstable air available in order to form thunderstorms. The highest concentration of lightning in parts of the world where warm and humid air exists for a large amount of the year. Then they have the weather's company's primary journalistic mission. All right, I won't read it. All right. So what we're talking about is if these areas of where you got land mass, and water physically change on the globe, well, guess what happens to the resonances? It moves to a different resonance. Literally the spherical cavity, what's happening is the spherical waveguide of the Earth and the ionosphere will have changed. So that is one of the resonant things that happens in the resonances is that shape, the form of it will change. Okay, so there's something else too. If the size and the shape of these land masses you have here were to change, you have a big land mass here, you look at how close to the equator it is, a lot of this activity is, and you can start understanding how they're connecting global warming with lightning activity and checking the temperature based on lightning. Okay, so if the equator moves, it'll affect the Schumann resonances in a certain way. It'll change the frequency of it because the waveguide will have changed. Those things that are constant now will become variables and they will change. But this does not answer the full question. There is more to this that I want to get into.